All right, so when you divide radicals, there's a couple steps. First step is rationalize the denominator. Basically, this cannot be a radical. If it's a radical, you have to get rid of it by multiplying it by itself. So even if there's a coefficient here, let's say that there was a 2, you take the radical and you square it. Don't even worry about the coefficient. Right? So if we square the radical here, we end up with 100, because the square root of 100 squared times itself, the radical cancels out and we're left with 100. So that's how we get from here to here. But you can't just multiply this fraction by the square root of 100 on the denominator alone. You have to do the numerator and the denominator at the same time. It's like taking 1/2 and multiplying it by 2 and 2 and getting 2/4. These two are the same, right? We have to keep this fraction and this fraction the same. Okay? So after we rationalize the denominator and we've multiplied the radicand and the radicand to get 800, we're left with this. Right? Now we have to simplify. That's the second step. So I'm going to take this and I'm going to use prime factorization to turn the square root of 800 into that. Okay, I'm looking for all of those squared terms that cancel out underneath the square root and, bust out of jail, so to speak. So I'm going to rewrite that as the 2 comes out, the 10 comes out, and the square root of 2 is left inside. And I keep my 100, obviously. Now I'm going to rewrite that. 2 times 10 is 20. And at the last step is if you have a fraction here, because this is multiplication, if you have a fraction that can be reduced, go ahead and reduce it. 20 over 100, if I divide by 20, divide by 20, I get 1/5, right? So my 1 is hiding there, and my 5 is on the bottom.